Good morning, everyone. Welcome to EagleDream's Tech Talks, all about artificial intelligence and machine learning. I'm Scott Weber, Vice President of Cloud Solutions at EagleDream Technologies, and I'm excited to be here today to talk to you about the art of the possible when using AWS's AI and ML tools and how we're helping customers leverage these tools to impact their business. First off, a little bit about who EagleDream is. EagleDream is a premier consulting partner in the AWS network. We help our customers strategically transform their businesses and redefine what's possible with technology. We are a group of innovators looking at the ways to use the latest technologies to help our customers. We are builders. We enjoy the challenge of building something that hasn't been done before. And we are recognized experts in the AWS ecosystem, having 3 AWS ambassadors on staff. We are the premier cloud-native transformation company in North America, helping our customers with cloud-native solutions built in the AWS cloud. So let's dive into what can we do in AWS with AI and ML. And I describe AWS's offerings around AI and ML as sort of a 3-layer cake. At the bottom layer is the core AI and ML technologies, the core frameworks, TensorFlow, PyTorch, and these types of tools. In the middle sits something called Amazon SageMaker, which has now evolved into a complete IDE framework for doing AI and ML work. But then at the top layer are what I call sort of the prepackaged AI and ML services. Things like Amazon Comprehend that can look at text and tell you the semantic meaning of the text. It can build word clouds. It can tell you what is the feeling of the people that spoke those words or wrote those words. AWS has a group of services sort of called the deep services, Deep Lens, Deep Racer, Deep Composer. We will talk about those in more detail in a little bit. Then we have things like Amazon Recognition, that you give it a photo and it will come back and tell you information about that photo. It can do object detection in the photo. It can tell you what's happening in the photo. There's no work that you need to do to build an AI or an ML model to do that. It's done for you. Amazon Transcribe for taking written text and transcoding that. Amazon Translate. In real time now, we can translate from one language to another in a call center setting. So let's think about this. If you're a call center and you need to be able to service both English and Spanish, you now don't have to worry about, do I have enough capacity on any one day for the languages that I need to be able to support? We can use something like Amazon Translate to, in real time, do language translation. Amazon Forecast. This is a model that was built off of how Amazon.com manages their warehouses. And it's available for any company to use. You simply feed it in your time series data, and then you can start asking it inferences about what could happen in the future. And one of the new ones is Amazon Fraud Detector. This is a service that, again, Amazon.com helped develop, and what they're using to identify when fraud might be occurring in Amazon.com. It's now available for customers to use. Let's take a look at how we're helping our customers leverage these tools from Amazon. And one of the things that I want to impress upon everybody today is when we look at how we're helping our customers, we're not doing it with teams of PhDs that are deep into these AI and ML frameworks. We're addressing this as a software development problem. So the first company I'd like to talk to you about is a company called Virtual Moving Technologies. They're based over in the Albany area of New York. So if anybody in the audience has ever gone through a multi-state move where you'd hired movers to come to your house, you're familiar with the fact that you're stressed out already about trying to make this move. Your house is probably a little bit of a mess. And somebody calls up and says, I need to come over and spend an hour going through your house to inventory your house to get ready to move. That's the last thing you really want to be worrying about at that point in time. So Virtual Moving Technologies had an idea. Could they leverage the power of the cloud and an application on your mobile phone to dynamically build the full inventory? And that's what they've been able to accomplish, leveraging Amazon Simple Storage Service, or S3, and Amazon Recognition. So now you, as a customer of the moving service, you will simply go room by room in your house, panning around and creating a video of each room. That gets uploaded to AWS's cloud, and a full manifest and inventory of your house is generated, along with estimations being made of the amount of space it's going to take up in the truck, how much is it going to weigh. Then they can also calculate how many boxes need to come with the movers on moving day to pack up all of your belongings. This application costs pennies on the dollar for the company to operate in the AWS cloud, and it was a software development problem. No custom models were created for this. This is using off-the-shelf, if you will, services from AWS. So one of our customers, 5x5 Technologies, is using drones to capture 2D images of cell towers and other structures, converting that into a 3D digital twin engineering accurate model of the object. And in this case, we're working on cell towers. As you can imagine, cell towers have a lot of detail, and they're critical infrastructure today. So we're capturing thousands of 2D photos from a flight of a drone and converting that into, in some cases, over 100 gigapixel 3D model. One of the challenges that we have is that, as you can imagine, as the drone operator is setting up their drone and getting their cameras ready, they may start to take photos of things that are not what we care about as we build our model. And these types of photos, pictures of the grass, pictures of empty space, empty sky, actually throw off our 3D modeling software and make it harder and more time consuming for it to converge to the 3D model that we want. So an AI and ML model was developed that sorts the photos when they're uploaded to say what has part of a tower, anything that resembles a part of a cell tower versus doesn't. So this was a simple model that was constructed using Amazon SageMaker. And this has improved the processing performance of the 3D model generation. But where could we take this? So as you can imagine, you have these structures that go through things like hurricanes, tornadoes. Things that start to become important are, is there rust on the structure? Are there cracks developing in the structure? Are the cracks growing? We can use ML processing pipelines to start to identify these things and track them. A more recent project that we're doing for 5x5 is we want to be able to catalog what is on the tower. We want to be able to identify the different antennas and structures that are attached to the cell tower. But not only that, we want to be able to then, on the next flight of the tower, 6 months to a year down the line, we want to also be able to tell what has changed on the tower. Currently, this is a very, very manual process of somebody having to look at the pictures, cross-reference that to diagrams of antennas, look for serial numbers, look for descriptions on the antenna. We're building a model today that is going to automate all of this. This is a critical feature for the companies that are providing the cell towers today. And because they sell the space on the cell tower to the cell company to put their equipment on, and they need to know what is on that tower. Another company that we're working with is Aerosafe. And this is a POC that we've built for them. Again, using tools like SageMaker and S3, TECHTalk, and other services from Amazon. Aerosafe has a very special cold shipping box. And what they'd like to be able to see is identify their boxes moving down one of their customers' shipping lines and pull off the shipping label and the metadata around where is the box going, because they need to make sure that they get their box back in a timely fashion. So we've built a model for them that can identify characteristics of their box that can then capture the shipping label. That shipping label gets sent into Amazon TECHTalk, and we can extract the metadata from the label and now know where the box is going. We can record that into their system so that they have better tracking of their own boxes, and therefore they can shorten their cycle time of their boxes and get more back into the system. So how do you get started on this AI and ML journey? There's 3 services from AWS and Amazon that are designed to help your team start to come up to speed on this. One is the Deep Racer. So this is the car that that allows your employees to learn how to build what's called a reinforcement learning model. And it's a little car, it looks like a little remote control car, except it's autonomous. And there's simulators that you can use online to help build the model. Then there's there used to be in-person races before COVID hit. Now they run simulations online as competitions. Sometimes there's a couple Amazon employees that are basically running races in their basements, where you can upload your model to put it on the car and you can actually see it go race. The Deep Lens is a small camera device that we've used to build our own POCs for our customers. It has image recognition built into it. You tie that into other services from AWS. And then there's the new service that just came out last fall, which is called Deep Composer, which allows people to start to explore generative AI. So you lay down off the keyboard a little bit of a riff, you hand it off to the AI, and it will start to expand upon what it heard and turn it into something much more. And again, there's knobs that you can turn on that as you tune the model for where you want it to take it. Here's an example of how we've done things with different teams around the Deep Racer. So we did an activity recently in the spring with universities in the area where we had teams from the universities get together. We gave them 3 weeks to build a model, and then they had 10 minutes to actually run various models on the cars on a track. Okay? These teams were able to get one of the fastest times yet of sub 10 seconds of getting the cars to go around the track. When Deep Racer was first announced by AWS, the fastest lap times were 51 seconds. Now the winning lap times are sub 10 seconds at any of the events that are being held. And it doesn't take a lot of money to do this, okay? These students went out, I think they spent probably less than $50 total in 3 weeks to build their model, but they've learned a lot about how AI and ML works. So in wrap up, you want to find ways to get your teams to start to explore this. So establish some ways that your teams can go and experiment, okay? Go out and get a couple Deep Racers, Deep Composers, Deep Lens cameras. Set up a hackathon one afternoon. Let the team see what they can do. There's already libraries of things that have been developed out on hackathons. Go out and take one of those ideas and take it a step farther. What can you do with the data that you have on your customers with these tools and services to inform your business, to take your business to the next level? But you have to experiment. And it's also a software development problem now. Not as much of having to go to the core frameworks like we were having to do in years past, is what can I do with the frameworks that AWS is providing me today from a software development standpoint. So thank you all for your time today. We are at the beginnings of the AI and ML journey for everyone, and it's going to be an exciting time as this continues to evolve. So thank you.